Hi guys, welcome back to my mathematics tutorial. Again, my name is Peter C. Junior, your math tutor. This is question number 21 on an implicit differentiation using natural logarithm. So we can also use the product rule to just differentiate this without using natural logarithm. We can use the product rule, that is, we can say, so let's use both roots. So we try the product rule first. So the product rule says if you have these factors, be it 3 factors, 4 factors, 2 factors, whatever factors the case might be, differentiate the factor one at a time. So we can decide to differentiate the first one or the second or the third, assuming we want to differentiate the first. So when you want to differentiate the first factor, you must hold the 2 other factors that you have. So the derivative of this factor is just 2. That is, we bring this 2 down. We rewrite what is in here, x plus 3. We subtract 1 from this power, which is just 1, times the derivative of what is in. The derivative of x is 1, derivative of 3 is 0. So we differentiated this first factor. Then we rewrite x plus 4 raised to the 3rd power and x plus 5 raised to the 5th power. That's raised to the 4th power. That's the first one. Then plus, we rewrite the first 2 factors and we differentiate the second. So the derivative of the second factor is 3. Bring this 3 down. Rewrite x plus 4. Subtract 1 from this 3 is 2. And then we can now rewrite. You can differentiate inside. The derivative of x is just 1. The derivative of 4 is 0. So one time this is just the same thing. So we don't need to write. So we can now rewrite x plus 3 raised to the 2nd and x plus 5 raised to the 4th. Then we can also differentiate the last one. So this coming down. We can differentiate the last factor. So this x plus 5 raised to the 4th. So we bring the 4 down. Rewrite x plus 5. Subtract 1 from the 4 is 3. And then we can now say, let's rewrite these factors. Now the derivative of x is 1. The derivative of 5 is 0. So we don't need to write it attached. What if this was x squared? Then we would have attached 2x to it. So times the first factor, x plus 3 raised to the 2nd power, and then x plus 4 raised to the 3rd power. So now we have to simplify, right? But this is what we can do. Now, here you have x plus 3. We have x plus 3, and we also have x plus 3. So we can factor out what is common. So y prime equals x plus 3. Now the power here is 1, the power is 2, and the power here is 2. So we take the one that is common to all 3 of them. So the one that is common to all 3 of them is this one. So the next factor we look for, x plus 4. X plus 4 is in this term, x plus 4 is here, x plus 4 is also in this term. So we say x plus 4. We look for the common factor, common exponent. So it's 3, it's 2, and then it is also 3. So it's 3, 3, and 2. So we take the 2. Then we move to the last one, x plus 5 raised to the 4th power, x plus 5 raised to the 4th power, and x plus 5 raised to the 3rd power. So we take x plus 5 raised to the 3rd power. So now we open parentheses. So if this x plus 3 goes into this, x plus 3 and x plus 3 will cancel, right? So now this 2, we put this 2 in here. Now also x plus 4 raised to the third. So if x plus 4 raised to the second is taken from within there, you just have x plus 4 raised to the first. Now x plus 5 raised to the third, you take 3 from within this power, you're left with x plus 5 raised to the first. That's the first one, right? Then we move to the second term. This is 3. 3 is there. X plus 3 raised to the first. X plus 3 is raised to the second. So if we take 1 from here, we're left with x plus 3. X plus 4 raised to the second. X plus 4 raised to the second. So everything is already out. X plus 5 raised to the third. X plus 5 raised to the fourth. So we'll be left with 1 factor, x plus 5 raised to the first. And then the last one, plus 4, x plus 3 raised to the first, x plus 3 raised to the second. So if we take 1 from within this 2, we're left with x plus 3. Then x plus 4 raised to the second, x plus 4 raised to the third. So we'll be left with x plus 4. And then the next one, x plus 5 raised to the third, x plus 5 raised to the third, everything is outside. So we can now simplify. So y prime now equals to x plus 3 times x plus 4 to the second, x plus 5 raised to the third. So let's see as to how we can just multiply these expressions. So let's multiply these expressions. Let's find somewhere to do that. Okay, so just do it right here. So the first expression, we have 2x plus 4. Okay, let's just multiply. So it's x times x squared times this. So it's 2x squared. X times 5 is 5x. 5 times 2 is 10x. 4 times x, 4x. 4 times 2 is 8. And then 4 times 5 is 20. 20 times 2 is 40. We'll do it for the next one. X times x is x squared. So this is 3x squared. And then x times 5 is 5x. 3 times 5 is 15. 3 times x is 3x. 3 times 3 is 9. And then 3 times 5 is 15. 15 times 3 is 45. And then last one, 4. So x times x is x squared. So it's 4x squared. X times 4 is 4x. 4 times 4 is 16. And 3 times x is 3x. 3 times 4 is 12. And then 3 times 4 is 12. This is 12. So it's 12 times 4. 4 times 2 is 8. And then 4 times 1 is 4. So now we can just sum them up. That is, if we add all of these in there, what we will get. So we're using the vertical addition. So the first one, you have 2, you have 5, you have 9. This is 9x squared. And then you have 10, 20, 30, 40, 41. 41x. And here you have 10, 20, 29, 29x, and then plus, so this is 40, 40, 40, which is 12. And then, okay, let's take this one first. 5 and this gave us 13, right? So we add 1 to this. So this is 8, 9, 10, 11, 12, 13. And what is here, repeating here, we can add them. They are like terms. So finally we will have 9x squared. 40 plus 20 is 60, 70. So it's plus 70x plus 133. So this is how we find the derivative of this expression using the product rule. So now, remember our answer. Let's use the implicit differentiation method and that of the product, the natural logarithm, and get the same answer. So I'm just going to write this one down here. So we have y prime to be equals x plus 3, x plus 4 raised to the second, x plus 5 raised to the third, and 9x squared plus 70x plus 133. Okay. So now we use implicit and that of natural logarithm. So we take the ln of both halves. Now because all of these factors, they are all factors of each other, so we can just take the ln of both halves. Remember, the ln of a times b is equals to the ln of a plus the ln of b, or the ln of a times b times c times d, and so forth, whatever the case might be, no matter how many of them, it's just equals to the ln of a plus the ln of b plus the ln of c, and so forth. So we take the ln on both sides. We have the ln of y equals to the ln of x plus 3 raised to the second power, x plus 4 raised to the third, and x squared plus 5 raised to the fourth. That's the first step. The next step is that these factors are all representing a, b, and c. So this is a, this is b, this is c. So we're going to have the ln of a, which is x plus 3 raised to the second power, plus the ln of b, which is x plus 4 raised to the third, plus the ln of c, which is x squared. It's just x, not x squared. Remember, we're just saying if it was x squared, then we would have differentiated x squared to be like 2x. So it's not x squared. So it's x plus 5 raised to the fourth power. So another property is the ln of a raised to r equals to the ln of a equals to r, the ln of a. So this is a and this is r. So ln of y is equals, we bring this power down, is 2 the ln of x plus 3 plus this is 3 the ln of x plus 4. This 4 comes down, 4 the ln of x plus 5. Then we can now differentiate. So it's 1 all over y times the derivative of y, which is y prime. So this is 2 times 1 all over the derivative of ln of x plus 3 is 1 over x plus 3 times the derivative of x is just 1. Derivative of 3 is 0. Plus 3, derivative of this is 1 all over x plus 4 times the derivative of x is also 1. Plus 4, derivative of the ln of x plus 5 is just x plus 1 over x plus 5 times the derivative of x plus 5, which is just 1. Now what do? We can find the LCD on the right hand side of the equation. So we have y prime over y. So we can find the LCD. The LCD is just this factor times this factor times this factor. So it's x plus 3 times x plus 4 times x plus 5. So x plus 3 into this, x plus 3 will cancel. You just left with this one. So it's, remember there's a coefficient right here. So it's 2 x plus 4 times x plus 5. And then plus, this is 3. So this denominator goes into this LCD. X plus 4 will cancel. You will left with x plus 3 times x plus 5. And then finally, x plus 5 goes into this LCD, x plus 5 will cancel. You just left with x plus 3 times x plus 4. So we can now multiply the numerator. So this is similar to the vertical multiplication that we did. So the vertical multiplication, you have this first one. So it's x times x. This is 2x squared plus 10x, x times 5 times 2 plus 4 times 5 times 2, 8x, 4 times 5, 20, 40. Next one, we have 3x squared, x times 5 is 5 times 3 is 15x, 3 times x times 3 is 9, and then 3 times 3 is 3 times 5 is 15, 15 times 3 is 45, and then plus x times x, so that gives us 4x squared, x times 4, 4 times 4 is 16x, 3 times x times 4 is 12x, and then 3 times 4 is 12, times 4 is 48. So we add, we just have 5 and 9, 9x squared. This is 10, 20, 30, 40, 41. 10, 20, 30, 40, 41x plus 10, 20, 29x plus 40, 40, 40, 120, 130, and 133. So we have like terms right here. So this gives us 9x squared plus 40 plus 20 is 60, 60 plus 10 is 70, so it's 70x plus 133. So the entire numerator is just this expression. Now we must multiply it by y. So what is our y? This is our y. So we have y prime to be y times 9x squared plus 70x plus 133. So you notice that I replace this y with what you have here. You will just have x plus 3. Okay, so we have denominator. Let's be careful of how we do it. So let's erase this one. Okay, so we have y prime now to be, this is y, and then this numerator now is just 9x squared plus 70x plus 133 all over x plus 3 times x plus 4 times x plus 5. So this y now, you have to replace this y with x plus 3 raised to the second power, and then x plus 4 raised to the third, and x plus 5 raised to the fourth times 9x squared plus 70x plus 133 all over x plus 3, x plus 4, and x plus 5. So what do you observe? Observe that this will cancel 1 from here. So we'll just be left with x plus 3. This will also cancel 1 from here. We'll be left with x plus 4 raised to the second. And then this will cancel 1 from here. We'll be left with x plus 5 raised to the third. And then times 9x squared plus 70x plus 133. So you see the two answers are all the same. So it's up to you to select which one of the methods you think will be suitable for you if you have a problem or such. So thanks ever so much for watching, and see you in our next lecture. Thank you.